The Cutter-ZGE-285 board is one of our most popular products, primarily down to its functionality. The board can take 12 LEDs and can be produced with a resistor to enable 12 LEDs in series, or leaving the resistor off and with the 4 termination points allows for the board to be run as 2 separate channels of 6 LEDs per channel. The LEDs are offset so the coverage of each 6 LEDs per channel is even across the board. The board, as you may guess, is 285mm in length and 20mm wide. It's an aluminium printed circuit board, 1.65mm in depth for optimum thermal performance. The board is aimed at the DIY market, and as such we get lots of questions about its use and function. So I hope I can address some of these questions for anyone who has purchased the boards or anyone considering buying them. As always in DIY, it often takes a village, so share with those that may benefit. Give us a thumbs up, or if you're not happy, feel free to say why. And please, subscribe. I wanted to address a common chestnut first. What is A1, A2, C1 and C2? So most of our boards use the standard notation. Simply A equals anode, which equals plus or positive, and C equals cathode, which is negative. Next, I wanted to cover the ability to use the board as a 2-channel board. This key function is useful for many applications, but if we consider this in the context of a light for horticultural applications, I will explain some of its benefits. An obvious application would be supplemental light. You have bought a light or lights, but spectrally you may find either some shortcomings or lack of photons and or a combination of both. A great application is to have one channel on end of day cycle using the Emerson effect and far red LEDs, while having the second providing just more 660. Or perhaps you have a light with a heavy red content causing some stretch issues. You could balance that off with some blue. Or perhaps you're trying to imitate a metal halide or HPS spectrum and need a green-orange spike. We have countless spectrum options with this board that can provide backfill to your existing light without a wholesale replacement. I want to demonstrate a functioning board set up for 2-channel control. We will need a driver for each channel, and we're going to use a simple compact approach here. We start with an AC-DC power source. I'm using a 480 watt Meanwell driver. This version is a standard constant voltage with no dimming. To test a single board, 480 watt may appear to be overkill, but it's what my test rig is set up with, and the board will only take the power it requires. The key point here is a constant voltage output is what I need. I require this to power the Cutter-ZGE drivers. The CUE are DC to DC constant current LED drivers and will power up to 90 watts max. 2 of these will drive the 2 channels of the 285 board. So while I could just run the CUE drivers straight up full power, that would lack the nuance of spectrum control. So I will control the PWM dim lines on the CUE with a StormX. This is akin to an Arduino type controller, and with 16 PWM outputs makes a very useful control tool for up to 16 CUE drivers. For this example, we're keeping it simple and using 2 CUE drivers and 2 PWM outputs to control our 2-channel board. The complete parts list for this setup is in the description below. The layout for this is AC into the Meanwell driver. The LED output on the Meanwell goes direct into the LDD4 carrier, which is holding the 2 CUE drivers. We are just using 350 milliamp versions for this. At this point, the CUE are effectively powered. We now need the PWM pins on the CUE controlled, so we introduce the StormX controller. We're going to use 2 of the PWM outputs from the Storm and wire that to the PWM inputs of the LDD, where we have the 2 CUE DC to DC controllers socketed. We then need the LED drive outputs on the CUE connected to the 285 board. So we take the two positives and the two negative wires / outputs from the LDD and match that to the A1, A2 and C1, C2 on the 285 board. We now have a completed circuit. Let's power up. To start, ensure the Meanwell driver and the plug pack for the Storm X is plugged into mains. Also that the output Storm jack is plugged into the side of the Storm X. The backlight of the Storm will come on and you will be at the first menu item on the Storm. The Storm X menu is quite deep and nested, and at this point all we want to do is to address two PWM channels so that all that is required is a long press to access the user interface. We will use the PWM day settings. Once you press this, you will have access to 16 channels. One press will lock to that channel, and turning the pot on the Storm will provide 0 to 4096 dim steps. You can set a dim level, press the pot again and turn once to advance to the next channel and repeat that process. For this example, I'm going to use channels 2 and 3 as that's how I have the setup wired up. As you will see, you can toggle back and forth on these two channels. You can either just set at full power or tune or balance the two strings on the board. I have loaded up 10 spectral charts of the board to demonstrate the spectral power distribution as an example of how you might select settings specific to your needs. These examples show how one wavelength can be set and the second could then be adjusted to balance SPD for a given application. I should note the setting of par from a single output does not change in terms of photons, which the changing charts might seem to imply. This is just showing the relative power of one wavelength to the next. In this example, our key goal might be to have a nice supplement of 660 nanometer to boost flower, while at the same time finding a desirable level of UVA to apply to enhance flavor, control spores, etc. Total par levels would need to be adjusted specifically at a total system level.